Hello guys, my name is Mohammad Izhaan Khan. Currently, I'm pursuing my bachelor's degree in civil and environmental engineering from IIT Patna. So today we'll conclude our topic on biomolecules. We have run till question number 50th and we'll be starting from there onwards. So question number 50. How do you explain the presence of an aldehyde group in a glucose molecule? Okay, so you should know this solution that glucose reacts with hydroxylamine hydroxylamine to form a monooxide and adds one molecule of hydrogen cyanide to give cyanohydrin. So this is the proof that you have to remember for the presence of an aldehyde group. Example, if I write the equation for this whole thing, aldehyde group CH2OH whole 4 and again CH2OH plus hydroxylamine and H2OH. So CH double bond NOH and rest the same things CHOH whole 4 and CH2OH. This is glucose oxide, and when this glucose oxide will react with HCl, then it will form glucose cyanohydrin CHOH, CHOH, Cn, and CHOH whole 4 and CH2OH. So this is what glucose cyanohydrin. All right. Moving on to the next question. Question number 51st. Which moieties of nucleosides are involved in the formation of phosphodiester linkages present in dinucleotides? What does the word diester in the name of linkage indicate? Which acid is involved in the formation of this linkage? See, nucleosides are linked to phosphoric acid at 5 position of sugar moiety to form a nucleotide. Alright. Then if we talk about nucleotides, that means two molecules are joined together by phosphodiester linkage. So this linkage will be between what? 5 and 3 carbon atoms. Okay. So phosphoric acid is involved in the 5 to 3 carbon atom linkage. I'll show you how. Suppose this is a sugar. This is a sugar. On top of it, you have a base. Okay. This is carbon number 1, 2, carbon number 3. You can have something over here. Carbon number 4, but this is carbon number 5. And to it, you have P double bond O, single bond O, single bond O minus. And this chain will keep on growing. How? P double bond O, single bond O, single bond O, single bond O. And from this O, you have again 5 carbon because you will have a sugar over here. So 3 to 5. This is 3. This carbon is 3. And this carbon is your 5. Question number 52nd. What are glycosidic linkages? In which type of biomolecules are they present? See, two molecules of monosac are joined together by an oxide linkage, which is formed by the loss of water. So such a linkage will be called as a glycoside linkage. We have to do it. Glycosidic linkages. When two molecules of monosac are joined by an oxide linkage. Are joined by an oxide linkage by the loss of water. By the loss of water. Okay. And now these linkages are present where? Present in disac, trisac, polysac. Now question number 53. Which monosaccharide units are present in starch, cellulose, and glycogen, and which linkages link these units? So in starch, we already know alpha glucose is present. Starch, alpha glucose, okay. And in cellulose, you have beta D glucose. Okay. In starch and glycogen, glycosidic A linkage is present, and in cellulose, glycosidic B linkage is present. So starch plus glycogen has glycoside, glycosidic A linkage. Meanwhile, cellulose, cellulose has beta linkage. Okay. So next question is question number 54. States how do enzymes help a substrate to be attacked by the reagent effectively? See, active sites of the enzyme is a structure like this. Suppose, okay, it is something like this. And now what will happen is it will hold the substrate molecule here. So the substrate will be held over here to be attacked by what? To be attacked by what? By the reagent. So the function of enzyme is what? To hold the substrate molecule in a suitable position to be attacked by the this reagent, and this should be effective. All right, this is the function of an enzyme. Describe the term D and L configuration used for amino acids. Okay, so the sugars are divided into two families. See, a sugar can be divided into two families, D and L. Okay, now these are basically what? These are configurations and are used to represent. These are represented with respect to glyceraldehyde as the standard. Now, the glyceraldehyde may be of two forms: D plus glyceraldehyde and L, any minus glyceraldehyde. The D configuration has OH attached to the carbon with adjacent to methanol group on right, while L configuration will have the OH of the methanol on the left. So, if I need to draw it, CH2OH. Next is this carbon atom, because there is something over here which is a long chain. There will be an H group over here and there will be an OH group over here. So since this OH is on the right side, so it will be your D configuration. And similarly, if we can uh, just reverse this situation over here, OH is on the left, so left to L, otherwise D. See, there will be a chiral carbon, and this chiral carbon should be the next one to CH2OH. This carbon will have OH in which direction? This will describe its D or L configuration. Now, hopping on to question number 56. How will you distinguish between 1 degree and 2 degree hydroxyl groups present in glucose? See, in chemistry, whenever such kind of a question comes, na, that how do you know that there is a glucose? How do you know there is a aldehyde in this compound, or 1 degree or 2 degree alcohol? So such questions are to be solved using reactions. You have to show using reactions, all right? So basically, you cannot do it like if you already don't know what reaction to state, then it will be difficult for you. So basically, you have to learn some reactions regarding it. that this is the proof for 1 degree and 2 degree hydroxyl group presence. This is the equation for the presence of aldehyde. So that way it will be done. So if you need to see, I can show you for this what you have to do. You have to glucose plus 5CH3CO whole twice O anhydride. This will generate what? This will generate CHO, C double bond O, C double bond O, CH3 whole 4, CH2, C double bond O, CH3. This is called glucose pentacetate. Okay. Now on its oxidation, it will form what? Saccharic acid, and it will be fruit. So 57. Coagulation of egg while in boiling is an example of denaturation of protein. Explain it in terms of structural changes. See, when an egg is boiled, the soluble globular protein, albumin, which is present, it will be converted into insoluble fibrous protein. Initially, when the egg is in its liquid form, it has globular albumin, globular protein, globular protein, that is albumin present. Okay. Now, when it will be boiled, this albumin, it will be converted into insoluble fibrous protein. It will be converted on boiling to insoluble fibrous protein. All right. So, also in this, you don't have to remember, but since there's a question on it, if you'll do this conversion, then there are some points that you need to remember that the biological activity is lost. Obviously, it is lost. Secondary and tertiary structures of albumin protein are destroyed, while the primary structure in which the sequence of alpha amino acid is named, it will remain intact. All right. Now, moving forward to question number 58. Match the vitamins given in column 1 with the deficiency disease they cause given in column 2. Okay. So, vitamin A, xerophthalmia is also there, and night blindness is there. So, vitamin A की वजह से सी xerophthalmia and night blindness. Alright. Next up, vitamin B1, berry. Vitamin B1 की वजह से है G, very. Alright. Now, number third is vitamin B12. Vitamin B12 पहला ही वाला है. B12 has A, pernicious anemia. Okay. Number four, beta C. beta C की वजह से है bleeding gums. Now beta D की वजह से तो हो जाएगा rickets. rickets कौन सा वाला है? rickets is D. और भी कोई है? Last one, I. Ostemomalacia. beta D, then beta E. beta E की वजह से होगा muscular weakness. muscular weakness. And last, beta K. beta K की वजह से क्या होगा? B, increased blood clotting time. blood clotting Time increased. Now question number 59. Match the following enzymes given in column 1 with the reactions they catalyze given in column 2. Okay. So number 1 is invertase. Invertase hydrolysis of cane sugar. This is the right one cut D. Now second maltase. Maltase का function है decomposition है hydrolysis of maltose into glucose. C. Number third है pepsin. So pepsin का है hydrolysis of protein into peptides. Number fourth, urease, decomposition of urea into ammonia and carbon dioxide. Number fifth, last एक B ही बचा है, so zymase, conversion of glucose into ethyl alcohol. Now assertion and reasoning type of question. Assertion है question number 60th. D plus glucose is dextrorotatory in nature. D represents its dextrorotatory nature. D corresponds to the position of OH group. Okay, so you have to choose from these options. And option number C. Assertion is wrong statement and reason is C. Assertion is correct and reason is wrong. So C. Option number 3 over here. D corresponds to the position of OH group on the right side on the farthest asymmetric carbon atom. Okay. So assertion is true, but the reason is incorrect. Question number 61 now. Vitamin D can be stored in our body. Vitamin D is fat soluble. Okay, both are correct. Assertion, reason, both are correct, and reason explains the assertion. 62nd. Beta glycosidic is present in maltose. Mhm. Maltose is composed of two glucose units in which C1 of one glucose unit is linked to C4 of another. Reason is correct, but assertion is wrong. 62nd. Moving onwards to 63. All naturally occurring A amino acids except glycine are optically active. Most naturally occurring amino acids have L configuration. All alpha amino acids except glycine contain at least one chiral carbon. So in this case, assertion and reason both are correct statement, but reason will not explain the assertion correctly. Now, hopping on to question number 64. The assertion is deoxyribose is not a carbohydrate. And the reason given here is carbohydrates are hydrates of carbon. So compound which follow CxH2O whole Y formula are carbohydrates. So in this case, what I can say, assertion and reason both are wrong. Alright, because deoxyribose is a carbohydrate and is the sugar moiety of DNA. Carbohydrates are optically active polyhydroxyaldehyde or polyhydroxyketone. Yeah. So question number 65. Question number 65. Hmm. Glycine must not be taken through diet. It is an essential amino acid. Glycine must be taken through, right? Okay. Okay. So both the session reason are wrong because uh, glycine can be synthesized by our body. It is not an essential amino acid. Okay. Now question number 66. In presence of enzyme, substrate molecules can be attacked by the reagent effectively. Active site of enzymes hold the substrate molecule in a suitable position. In presence of enzyme, substrate molecule can be attacked by the reagent effectively because of the active sites of the enzyme hold the substrate molecule in a suitable position. So assertion and reason both are correct over here. Now we have long answer type. Write the reactions of D-glucose, which can be explained by its open chain structure. How can cyclic structure of glucose explain these reactions? See, the open chain structure of glucose explained most of its properties. However, it could not explain some of the facts. Okay, open chain couldn't explain the following fact. Number one, despite having an aldehydic group, glucose does not undergo certain reactions of aldehyde. Despite having CHO, glucose does not undergo aldehydic reactions, which are glucose does not react with ammonia, glucose plus ammonia don't react. Glucose does not react with sodium bisulfite. Number second, glucose plus sodium HSO3. It does not react. Glucose does not give Schiff's test and twofold DNP test like other aldehydes. Glucose fails Schiff's test and 2 power 4 DNP test. Okay. Point number two. Glucose reacts with hydroxylamine to form an oxime, but glucose pentaacetate does not react with hydroxylamine. This shows that CHO group is not present in glucose pentaacetate. Alright. So glucose reacts with hydroxylamine to form oxime, but glucose pentaacetate does not react with hydroxylamine. Next two words does not react. Okay. D plus glucose exists in two stereoisomeric forms, alpha D glucose and beta D glucose. These two forms are crystalline and have different melting points and optical rotations. If you want another point, you can also note an aqueous solution of glucose shows muta rotation. Its specific rotation gradually decreases from 110 degree to 52.5 degree. In case of alpha glucose, an increase from 19.7 degree to 50.5 degree in case of beta glucose. So these results show that glucose does not have open chain form of structure. On the basis of which evidence the glucose was assigned the following structure. Okay. So first of all, how do you assign a structure to a compound? The structure will be assigned based on the basis of some of the evidence which you have. So first of all, the molecular formula number one. You will know that molecular formula is C6H12O6. Okay. Now state chain structure. Okay. First of all, you would assume that it is a state chain structure. So CHO, CHO, H whole 4, CH2OH. In the presence of two hydrogen, sodium amalgam will give you what? CH2OH, CHOH whole 4, and CH2OH. So this is called sorbitol. When aqueous solution of glucose is treated with sodium amalgam, it is reduced to sorbitol. Then prolonged heating with hydriodic acid and red phosphorus at 100 degrees gives a mixture of N-hexane and 2-iodohexane. Alright. So this proves that it has a state chain structure. Now presence of 5 hydroxyl OH groups. Number third, presence of 5 hydroxyl groups. On acetylation with acetic anhydride, glucose will give a pentaacetate. Okay. glucose plus anhydride will give you a pentacetate. The five hydroxyl groups will be converted to what? Acetate groups. So this will show that glucose will contain five OH groups. We know that the presence of two or more OH group on the same carbon atom makes the molecule unstable. Now, since glucose is a stable compound, therefore five OH group must be present on different carbons. See, suppose there are two OH on the same carbon, and if the both are reduced to acetate, then it will be unstable. So, since glucose is a stable compound, this means that each carbon has their own OH five times. Got this point? Pentacetate. Presence of one primary alcoholic group. Okay. Since CH2OH, which is initially there, it is a primary alcoholic group. On oxidation with nitric acid, both glucose and gluconic acid gives the same dicarboxylic acid, saccharic acid or glucaric acid. A primary alcoholic group CH2OH is always present at the end of the carbon chain. Now, lastly, presence of an aldehyde. Glucose plus hydroxylamine to form CHO oxime, which suggests that glucose contains a carbonyl. Okay. On the basis of above observation, the following open CH2O chain structure can be assumed. CHOH whole 4, then CH2OH. Next question, question number 69. Carbohydrates are essential for life in both plants and animals. Name the carbohydrates that are used as storage molecules in plants and animals. Also name the carbohydrate which is present in wood or in the fiber of cotton cloth. So carbohydrates that are used as storage molecule in plants and animals are as follows. Plant contains mainly number one. Plants contain mainly starch, cellulose, sucrose, etc. Animal contain glycogen in their body. Glycogen. So glycogen is also known as what? Animal starch. Animal starch. Glycogen is present where in the liver, muscle, and brain. When body needs glucose, enzymes breaks glycogen down to glucose. And number third, cellulose is present in wood. Cellulose is present in woods and fiber. Now, hopping on to question number 70. Explain the terms primary and secondary structure of protein. What is the difference between alpha helix and beta plated sheet structure of protein? Primary structure. Proteins may have, first of all, I will primary, primary structure. Proteins may have one or more polypeptide chains. Proteins की अगर बात करें, proteins have one plus polypeptide chain. Each polypeptide chain have a large number of A amino acids linked to one another in a specific sequence. The specific sequence in which the various alpha amino acids present in a protein will be linked is called its primary structure. Any change in this primary structure sequence of amino acids creates a different protein. Okay. Now these chains these contain amino acids. Okay. These are joined to some sequence. If this sequence is unchanged, it will be what? It will be the primary structure. Simple. Now, if you talk about if this sequence is changed, suppose there are amino acids and there are sequence. So if this sequence is changed, then you'll get what? A different amino acid, a different protein. Alright. So the primary structure of protein is usually determined by its successive hydrolysis. Now secondary structure. The secondary structure gives the manner in which the polypeptide chain are folded or arranged. Therefore, it gives the shape or conformation of the protein molecule. This tells about the shape of protein. The primary structure decides what protein is there, and the secondary will decide the shape of the protein. Now, there are two forms: alpha helix structure and beta pleated sheet structure. There are alpha helix and beta pleated sheet structure. Write the structures of fragments produced on complete hydrolysis of DNA. How are they linked in DNA molecule? Draw a diagram to show pairing of nucleotide bases in double helix of DNA. Okay. Complete hydrolysis of DNA yields pentose sugar, phosphoric acid, and nitrogen containing heterocyclic compounds called bases. So, if you want to draw the structures of it, then I'll start with sugar, OH, 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 CH2OH. This is sugar. Now, number two, phosphoric acid, phosphoric acid. Number three, OH, OH, OH. Nitrogen base DNA contains four bases: adenine, guanine, cytosine, and thiamine. So, nitrogen bases: adenine, guanine, cytosine, and thiamine. So, a unit formed by the attachment of base to one position of sugar is called a nucleoside. When nucleoside links to phosphoric acid at a 5 position of sugar, a nucleotide is formed. Nucleotides are joined together by phosphodiester linkages between 5 and 3 carbon atom of pentose sugar. This I have already told you, and hence this concludes our topic on biomolecules. So, further, let me just find some PYQs to give you a brief. See, accumulation of which of the following molecules in the muscle occurs as a result of vigorous exercise? Well, let's shorten the question over here. If you do vigorous exercise, then which of the following molecules will accumulate in the muscles? Which of the following molecules will accumulate in the muscle? I'll give you some options. You have a pyruvic acid, L-lactic acid, glycogen, glucose. The glycogen is stored in the liver. It is decomposed into glucose. Glucose is used by the muscle. L-lactic acid gets stored in the muscle, which causes the muscle cramps. If you have played cricket or football for a long duration, and afterwards when you come home, you must have faced such muscle cramps. So these are because of the accumulation of lactic acid. Which of the vitamins are water soluble? So you need to remember that vitamin C is a water soluble vitamin. Burette test is not given by C. Right question. Burette. Burette test is not given by proteins, carbs, carbohydrates, polypeptides, and urea. So this Burette test is not given by carbohydrates. Next question we have RNA is different from DNA. Why? Its solution is RNA is different from DNA because RNA contain ribose sugar as uracil base. Again, same question came, which asked which base is present in RNA but not in DNA. So the answer is uracil. The term the term anomers of glucose refers to. So the anomer is an epimer at the hemiacetal. Okay, an atom is called the anomeric carbon due to the stereoisomer of that compound. So the carbon atom at position 1 is anomeric. So solution is isomers of glucose that differ in configuration at C1 carbon. The pyrimidine bases present in DNA are the pyrimidine bases present in DNA are cytosine and thymine. Cytosine plus thymine. The secondary, the secondary structure of a protein refers to alpha helical. I told you alpha helical and beta pleated backbone. So hence this concludes our topic on biomolecules, and I will see you further on some new topics. So all the best till then. Bye bye.